Hello, my name is John Clyne. I'm from the National Center for Atmospheric Research in Boulder, Colorado. And today I'm going to be telling you about Project Pythia, which is a community learning resource for geoscientists. Along with myself, my co-PIs also from NCAR are Matt Long and Kevin Paul, Ryan May from Unidata, and Brian Rose and Kevin Tile from the University at Albany. I'll start out by providing a little bit of background to motivate Project Pythia. As many of you may know or have suspected, Python has in recent years become the most widely used programming language for the sciences. This is no doubt due in part to the emergence of the scientific Python ecosystem, a vast and ever-growing collection of community-owned scientific packages or utilities. Another recent development is the emergence of Jupyter Notebooks as a simplified web-based platform for programming, creating shareable, documented workflows, and supported back-end computing on Big Iron. Lastly, we're seeing an increasing demand for moving workflows to public clouds and making HPC workflows more portable and shareable. So this is just a small snapshot of the more popular components of the scientific Python ecosystem. And you'll note that the packages at the bottom are more general and become more specialized and discipline focused towards the top. There are many more packages that are not included in this diagram, but again, I just wanted to give you a sense of the extent of the scientific Python ecosystem. So what then is the problem? Well, the scientific Python ecosystem is a bit like a two-edged sword. There's a tremendous amount of capability, but often at the cost of having an overwhelming number of choices confronting the user. Users must contend with questions like, with so many packages, often with overlapping functionality, which package should I choose? Will a set of packages interoperate together, and which versions are compatible? Often this is not the case. Will the package that I built my workflow on be around a year from now? Many ecosystems components tend to come and go. Can I trust the results? This is a big one. How do I know, for example, that the developer correctly implemented a particular algorithm? Where do I turn for help? There's rarely a support desk for community developed software. And how do I make general purpose function work with my particular data? In addition to ecosystem issues, cloud computing for science is still an emerging technology trend with not a lot of standardization across providers. The bottom line, it's simply complicated to use. So the goals of Project Pythia are twofold. First, we plan to develop and operate a searchable online web portal that provides geoscientists at any point in their career, from beginning students to seasoned veterans, with the educational content and real-world examples needed to learn how to effectively use Python and the multiple packages that comprise the scientific Python ecosystem. Second, because we believe cloud computing holds so much potential for our community, we plan to develop lightweight binder-based tools that will make it trivial to launch portal content in customizable, executable environments in the cloud. To meet these goals, we will provide the Pythia portal, a public web-accessible resource that will contain a variety of educational material. The format of this material will be reproducible Jupyter Notebooks, which we expect that the bulk of our content will be delivered in this form. sample downloadable data, training videos, self-paced tutorials, and external communication channels for communicating with peers. Lastly, we anticipate providing many links to external content. We're not going to reinvent everything from scratch. In terms of subject matter covered by the Pythia portal, everything from getting started with Python for the first time to advanced topics such as scalable programming with Dask or migrating workflows from the desktop to the cloud will be covered. The second component of Project Pythia is the Pythia platform, which will simply provide the binder-like utilities that transparently support interactive cloud execution environments for each of the Jupyter notebooks found in the portal. We plan to target all of the major cloud resource providers, Amazon, Azure, Google, and so on, as well as HPC environments. To sum it all up, the Pythia platform will provide a public, web browser accessible collection of training resources. One of the primary delivery mechanisms for content will be galleries of Jupyter notebooks running Python kernels. These notebooks can be downloaded and run locally, or might be executed in the cloud via a binder-based Pythia platform. The latter, among other advantages, allows the scripts to be run where the data reside. I wanted to take a moment to say something about open development. Project Pythia will be a community-owned resource and will embrace an open development model similar to those successfully employed by Python projects such as Dask and Xarray, to name only a couple. The success and long-term viability of Project Pythia will depend on how successful we are at engaging our target user community. The Pythia community is expected and encouraged to contribute in many ways, such as providing feedback on the Project Pythia resources, helping us identify and prioritize content needs, but also helping develop new content or identifying existing content for inclusion, responding to questions from other users, reporting and even correcting problems, and much more. To facilitate open development, all Project Pythia developed content will be hosted on a public GitHub repo. GitHub provides all of the machinery to make open development a viable option for projects like ours. So hopefully you're thinking that Project Pythia sounds like an awesome community resource and you are wondering when you or your students can make use of it. Well, there's a draft version of the Pythia portal available now. You can find it at the URL below. The portal is currently very much a work in progress. There is little or no actual content on the draft website, but you can certainly find information about the project and information on how you can get involved. We are planning to release a version 1 or a usable version of the Pythia portal in summer of 2021. This will certainly not be the end or all of the content that will be provided on the portal. We anticipate adding content throughout the duration of this funded project and well beyond that with the help of the community. And then lastly, we will be releasing the Pythia platform in the summer of 2022. So to summarize, Project Pythia will be a community-owned educational resource for helping geoscientists at all levels of their career become proficient with the scientific Python ecosystem. Because of the recent surge in interest and the potential offered by cloud computing, A particular focus will be placed on scalable, cloud-ready workflows. Lastly, Project Pythia will follow the open development model. Community engagement is essential for success. We need your help and ask you to please get involved. Please check out the Project Pythia website for information on how you can become part of the Project Pythia community. I want to wrap up with a few acknowledgments. First, I of course want to thank the NSF EarthQ program for funding Project Pythia. I also want to thank the Pangeo community for all of the engagement that we've had with them, but also for doing so much to promote the use of the scientific Python ecosystem by the geosciences community. And then lastly, I want to thank the many technical staff that are involved in doing all of the heavy lifting at our respective institutions. So thank you.